Okay, so in this video, we are going to be talking about Arduino motors and specifically the motor driver. So I'm just going to start with talking about some really basic things. So we have our blank template or blank sketch, if you want to call it that. I'm basically just going to talk about the pins. So we have two types of pins on the Arduino board. We have A pins and D pins. One is for digital write, a certain command, and analog write, which is another command. I'll get into more about it later on, but pretty much we're going to be talking about the digital pins in this situation. And so pretty much there's certain digital pins that allow analog write. And that's a command that we're going to need for certain functions that I'm going to discuss later on. Um, but yeah, so these certain pins, there's more than four, but these are the four I'm going to be focusing on. I'm going to focus on pin 6, 9, 10, and 11. There's a couple more, but we don't need to worry about that because we only need two for each motor. So as you can see, we're using the hashtag define keyword. Instead of like typical programming where you use declare a variable, this is less hard-coded and it's known as more of a best practice when it comes to Arduino. And you're probably wondering, why are there two pins per motor? Each pin corresponds to a terminal on a motor, and this is really important for when you want to control direction, because you're going to be sending a signal to each of these terminals, which will control the direction for when you want to move like backwards or forwards, for example. We'll get into more about it later on when we talk about more of the functionalities of the motor. So we're not done basically setting up the pins. We also need to add something to the setup, which is pretty much just a couple functions called pin mode. Bring it over. So pin mode is just is a is a function, a part of the Arduino like software. Pretty much it just determines whether or not a pin is going to be an output or input pin. And so for the purposes of motors, it's all going to be an output. The reason why is if you think about like a sensor, basically let's talk about an ultrasonic sensor, for example. It's going to take an output. It's going to output like a frequency or like a wave, and it's going to take in a frequency and a wave to determine direction. So pretty much it's outputting something, but it's also inputting something. It's taking in an input. But for motors, we're simply just dictating speed, so it's purely an output, if that makes sense. So next up, we're going to be discussing the motor direction functions. These are some pretty basic functions that basically dictate moving backwards and moving forwards. If you know in the base, if you've watched the basic programming video, it basically goes into more depth about what this practice is. We're basically creating new functions to improve the code readability and modularity. It's just the best practice. And so pretty much these two functions dictate whether the Arduino should move forward, so the block should move forward or backwards. So pretty much digital write takes in two different commands. So first you want to declare the pin that you're outputting to, and you want to declare the signal. You want to indicate the signal, which can either be high or low for digital write. High pretty much means maximum speed, and low means minimum speed. So 0 versus 100%. And we have one for both motors, so one for left and one for right. And you know how I was talking about terminals at the start of this video. Pretty much, we're sending a signal to one terminal, maximum speed to one terminal, and minimum speed to another terminal. And as you can see here, when you switch them around, so this can be different for whatever bot you're using, but typically high is going to be the first one, low is going to be the second one, but that can be different for your bot. It won't make a difference because one's going to be the counterclockwise movement, one's going to be the clockwise movement. So when we set both to high, the left and right motor, obviously we're going to, and in the forward direction, you're going to be moving forward. And if you set both to low, and you basically are setting the other terminal to high, you're going to move in the backward direction. So it's the same thing pretty much. You can flip these depending on what you need, but it basically means the same thing. So moving on, we have the motor movement functions. So this is related to the analog write command. Bring it over. So with analog write, why it's really important and really good is that you can declare a variable speed. So a value between 0 to 255 specifically. So any value in between here is going to correspond to a percentage. So for example, let's say you pick 100. I think it corresponds to around like 30 to 40%. That's how much speed is going to go into those motors, which is really good for when you want to like make specific maneuvers, depending on what your strategy will be during the competition. But basically, it pretty much takes in a parameter. So whatever speed you indicate in like the main function, we'll get to the main function, but whatever speed you indicate, and pretty much the same thing as above, you're basically just implementing like the high and lows, but for high, you're implementing a speed. So it's going to be a value, a number, and so this moves forward at a certain speed, this will move backward at a certain speed. It's pretty much the same thing, but with just, you basically have more versatility with this command. Next up is the motor turning functions. So you have two pretty simple functions, turning left and turning right. Paste it here. So this is also pretty simple. It's going to take in a speed, so it takes in a variable speed depending on how fast you want to turn, how quickly you want to maneuver for right and left turns. So if you want to think about this logically, one motor is moving backwards while another is moving forward. So in this case, the left motor is moving backwards while the right motor is moving forwards. So what does that mean? It's going to mean that you're rotating left. And likewise, so counterclockwise rotating left. And likewise, when you want to turn right, you're going to flip these values. So pretty much one's going to move, the left motor is going to move forward while the right motor moves backward, which is going to be a clockwise. Which is going to be a clockwise rotation, which is turning right. So as simple as that, pretty much just input a speed, which can be a variable speed depending on what strategy you want. And the last function we have, pretty obvious one, is just going to stop the motor. So when you put in a signal, the same signal, basically what's being read into the motor is no direction. So if you think about it, one terminal is set to low and another terminal is set to low. There's no direction happening here. So pretty much you're at a standstill. So these lows signals can also be set to highs. If you wanted to, it will do the same thing. But you can do whatever you want. It doesn't really matter. So we're now just going to bring everything together in the main loop. This is what repeats repeatedly. So in the competition, this is what you're going to put all your main functionality into. So this is the code I have. You can test it with your bot, or you can switch this up and if you want to do some testing. But pretty much, I just want to talk about delay. Delay just, and it's in milliseconds or microseconds. I might be mistaken, but it's in milliseconds, I believe. So 1,000 milliseconds will translate to 1 second of delay. So your bot's pretty much going to be moving forward for 1 second. So each of these commands will be moving forward for the amount of delay you have indicated underneath it. So forward's going to be moving back by 1 second. Backwards going to be moving back by 1 second. You're going to be turning left at 40% speed. See, this is the 100 I'm talking about. You indicate 100. It's a value between 0 to 255. And so we have 100, which is 40% speed. And then we're going to delay this by 1 second. So it's going to turn left for 1 second, and then we're going to turn right for 1 second by the same logic as before. And then we just stop it. And we stop for 1 second. Because we're going to, when you stop motor, everything stops. But we're going to delay it. We're going to allow it to stop for 1 second because we're going to run these analog motor functions. So we're going to do the forward analog, which basically, as we discussed, is going to move at 40% speed forward. And then so we have the delay for 1 second. It's going to happen for 1 second. Backward analog for 150 speed. So you're going to move backwards at a little faster speed than 40%. It's going to be like around 50, around that, a little more than 50. And we're going to do this for 1 second. And then we're going to turn left at 40% speed and delay for 1 second, turn right for 40% speed, delay a second, stop motor, delay it for 1 second. So you don't really need this delay, but once you stop motor, everything will go at a standstill. But the code will technically still be looping, if that makes sense. So you can just disconnect or whatever you want to do with your bot. Pretty much that's it. If you have any questions, please feel free to put it in the Discord. I would love some feedback on this video. Yeah, and thank you for your time.